right, 13.1, use trigonometry with right triangles.
No. Is trigonometry like algebra and geometry had a baby?
Kinda.
There are no proofs, right?
No, not in here.
Jesus. Not about to go through that again.
I had to think about it because there are some things in chapter 14 that, like, I will prove for you, but not in the sense of the proofs where you, like, you write the statement and then you give the reason for, like, why you could do it with, like, a theorem. It'll just be, like, I'll show you, like, here's the initial thing that we know to be true. Here's how we get to the other thing. And the main reason I show it to you is in case you forget them and, like, memorizing. Like, if you don't want to memorize stuff, then you can, like, just know the pattern of how to get there.
The desks
But-
definitely shifted that way.
Yeah, they always do. No matter, I can literally start the day over here, and they're going to end up over there by the end of homeroom. Or the end of geometry. Both of those. Okay. Evaluate the 6 trig functions of the angle. So they're going to give us a triangle that is a right triangle.
Straight line.
So they're going to give us 2 sides, and then they're going to point out which angle that we're dealing with, and that's going to be because we're finding all 6 of our trig functions. Told you. It's already happened. Just stay. Okay. So to do that, we need to find the third side, and so we are going to use the Pythagorean theorem. So as a refresher, a squared plus b squared equals c squared. A and B are the 2 legs of the triangle. C is the hypotenuse. That's what I'm solving for. A lot of times I go straight to the modified version of this and just say C equals the square root of the other things added together to speed up the process. If you want to do that, you can do that. Up to you. But so C equals the square root of 8 squared plus 3 squared. So that's the square root of 64 plus 9, which is the square root of 73. If you can break it down, you should break it down. I can't think of anything that this breaks into. I think this might be prime. Yeah, I think it's prime. So we're going to leave it at that. But if it can be, then obviously, like I said, you need to break it down. So now I have all the sides. I'm dealing with this angle theta. So I'm going to set up to find all 6 trig functions. So I go ahead and set them all up. I'm going to have to turn this off or it's going to be trying to fix everything. And yes, you need to write them in this order, and you'll see why in just a second. So last year you probably dealt with sine, cosine, and tangent at least a little bit.
So hot.
I was thinking that too. I thought it was just me. Kelly, can you take the little dial and turn it to the left just like a little bit? No, the other way. Down. Yeah. Perfect. Thank you.
It was getting rather warm.
I was like, I'm roasting, but I was like, I'm technically sitting under the thing, so I wasn't really sure.
I am too, so
Yeah.
that makes sense.
Like when I sit right here, I can feel it. Like I either freeze or I burn up right here, basically. All right, so we're looking at this angle. So sine is opposite over hypotenuse, so that's going to be 3 over the square root of 73. As you may have guessed, or maybe not, but we cannot leave it this way. We cannot have a radical on the bottom, so we have to rationalize it. So we multiply by the square root of 73 over the square root of 73. Now, I'm not always going to write this step because eventually you'll just get used to doing it. But now my final answer then is 3 root 73 over 73. So if I have a radical on the bottom, I've got to multiply top and bottom by whatever is in the radical.
I wrote them too close to each other.
When you get really good, you won't even have to probably even write it this way initially. You'll be able to go straight to this answer, but for right now, I would write them this way so you don't get confused, and it'll make your life easier in a minute. All right, cosine is adjacent over hypotenuse, so that's the one that's touching it. So 8 over the square root of 73. So again, I multiply by square root of 73 over the square root of 73. So I'm going to get 8 root 73 over 73.
Tan is just 8 and 3, right?
Tangent is opposite over adjacent, so 3 over 8. So I don't have to do anything else to that one.
So chill.
Now, the reason that we set them up this way is, one, if everybody sets it up the same way, it makes grading way easier. But it also makes life easier for you because all I have to do to find cosecant is flip sine.
Oh, I see.
So square root of 73 over 3. Which is also why I like to write the initial this way as 3 over the square root of 73. Because then when I go to flip it, I don't have to rationalize it again. And then reduce and all the things. It already has it like rationalized for me. Secant, I flip cosine, so we get the square root of 73 over 8. And then cotangent, I flip tangent, so that's 8 over 3.
That's kind of easy. For now.
And that's your answer right there, are those 6 things, if you want to.
Those are just like our answers.
Just only do
Yep.
this.
So basically when I grade, I just go do, 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 and then do, do, do. And I just grade them down that way. But that's why if you put them in the wrong order, I'm probably going to end up marking things wrong because it's not going to be in the order that I'm checking them. So make sure you write them in this order. 8.
That's a big triangle. Wow.
That's big triangle. Big triangle. Oh, great. So we're finding the other side.
So this time they gave me the hypotenuse and one of the legs of the triangle. So I'm going to have to find the other one. So again, I kind of am just used to the formulas at this point that I can just quickly manipulate them to be what I'm trying to solve for. Because if you look at the original one, I know if I want to solve for one of the other sides, I'm just subtracting off one of the, whatever side I'm given. It doesn't matter if it's A or B. And then from the hypotenuse value. So a lot of times I will go straight to say A squared equals C squared minus B squared. I might even go ahead and take the square away from A and put it on all under the radical. Okay, this is just a manipulated form of the Pythagorean theorem. So A equals the square root of 2 root 17, and that whole thing is being squared, so I'm going to throw it in parentheses there. Minus 8 squared.
How do you? I'm a little lost here.
On what?
Okay. I don't know how to use square root.
Is
Isn't it just the
It's
same?
a
They just cancel each other.
Okay.
So this is going to be the square root of 4 times 17. So I'll write it right now.
Well, that's 4 times 17.
Minus 64. That's 8. Yep. So the square root of, I'm just going to write the 68 under there. Square root of 4, which is 2. So that's my other side.
You okay?
We have a number. Now we do the side.
Whoa.
Tangent. Tan.
Do you have to write that actual, what does that actual thing mean after sin?
The little
Okay, first of all, don't say sin. I get mad. It is sine, cosine,
Okay.
tangent,
Sorry.
cosecant, secant, and cotangent.
So what's the little like symbol after
Theta, that's of the angle, and yes, you have to have that.
Theta.
Oh wait,
I
look
had one of
those.
those.
I had a blue one.
What?
I also had a blue
The
one.
beta fish?
Yeah.
You can try to find one with
I've
red.
never had
the
one.
ones at the top don't.
I
because
named
have to
mine
go
Blue
through
Boy.
to find them.
Mine's like-
All right, sine of theta is opposite over hypotenuse, so that's 2 over 2 root 17. You can either go ahead and reduce from the beginning, or you can wait till you're done and reduce it, but I usually will go ahead and make my life easy and cross those out. So right now I have essentially 1 over the square root of 17. I need to multiply it by the square root of 17 over the square root of 17.
So it'll be root 17 over 17.
Yep. Now, I don't usually show that I'm rationalizing it by like showing what I'm multiplying. I just get to the answer because that should be something you can do in your head. So
Adjacent over.
I'll do that. So adjacent over hypotenuse is going to be 8 over 2 root 17.
Which is
I'm going to go ahead and
4.
reduce. So that's 4 over root 17, which is 4 root 17 over 17. Tangent, opposite over adjacent, so that's 2 over 8. If you can in your head go straight to the reduced value of 1 over 4, you're welcome to do that as well. When I get to cosecant over here, I'm flipping sine. But again, I'm going to use the original. However, I can already see that I reduced this and got rid of the 2's. So I can just go ahead and say this is just the square root of 17. Secant, I'm going to flip the original. I've already seen that I've reduced it, so I'm going to go to the square root of 17 over 4. And then cotangent, I'm going to use the reduced form, so that's going to be 4.
This is really.
Stop saying that.
Okay, so on those ones, they gave you the triangle.
This is your effort.
I will rarely actually draw the triangle for you. I'm going to probably give them to you the way that these next problems are given. So they're going to tell you that theta is an acute angle of the right triangle. What does that mean? What does acute mean?
It's adorable.
Less than 90 degrees. So I know that that has to be true. And then they're going to give me one of the 6 trig functions already. So they're going to give me one of them, and then I'm going to have to set up my triangle myself. So on 10, I have the cosine of theta equals 5 over 8.
So then you draw your triangle.
And it doesn't matter which way you draw your triangle. I tend to draw mine this way, but that's just me.
Adjacent over hypotenuse. How do you know which one is?
So you're just going to have to choose. But I typically am going to choose this to be theta down here just because it's easier to see, in my opinion. But that's just personal preference. It's just the way I've always done it. You could choose this one up here. It just is going to change where you put your stuff on your triangle.
So it's 5 and
So 5 goes here. 8 goes here. I need to find the other side. So I'm going to go ahead and say A is equal to the square root of C squared, which is 8 squared, minus 5 squared, which is, well, I'll get to that in a second. So then that's the square root of 64 minus 25. What is that? 39? 39. So this side is the square root of 39.
Can't you? What's that called?
Maybe. Let me think.
3?
I can take out a 3 and then, what is that? 3 and 13.
3 and 13. Yeah, that's it.
So there's nothing I can take out. So yeah, so we would leave it. But yes, I do need to check that. All right, so then setting them up, sine of theta, cosine of theta. Now, that one was given to me, but I'm still going to put it over here. Tangent of theta. All right, so at this point now I can find all my other ones. So what would sine of theta be?
Hold on, I gotta think. Opposite over. Root 39 over 8.
Yep, root 39 over 8. What about tangent of theta?
5?
opposite over adjacent.
Opposite.
TOA.
So root 39 over 5.
Yep. Alright, so then for the other ones I need to flip them, but notice I'm going to end up having to rationalize this time because I'm going to end up with the radicals on the bottom for this side. So this is going to be 8 over root 39, which is going to become 8 root 39 over 39. Again, if you feel like you can go straight to the answer rationalizing it in your head, you are welcome to do that without having to write the initial step, but it's up to you. Secant obviously would be the easiest one on a problem like this. If you get nothing else right, if they give you cosine, you should get secant right. Okay, if they give you sine, you should get cosecant right. You should be guaranteed that you're going to get at least one of the other 5 correct because they've given you one to start with. Okay, so even if you get this number wrong and you get the entire rest of the problem wrong, you can guaranteed, as long as you remember which trig functions go together, you're guaranteed to get at least one of them correct. Okay, so 8 over 5. And then this is 5 over the square root of 39. Yep, rationalize, we get 5 root 39 over 39. And watch too, because sometimes when you rationalize, then you can also reduce something. I can in this one, but just be aware of that sometimes it causes something else to reduce. So make sure you watch that as well. 12. Cosecant of theta is equal to 10 over 7. So a lot of times if they don't give me sine, cosine, and tangent, not that I can't figure out where these things go, but I will go ahead and set up all 6 trig functions, and like cosecant goes with sine, so I will go ahead and figure out what sine is, quote unquote, aka just flip it, and then I'll use that to set up my triangle. So if I'm given sine, cosine, or tangent, I'll go ahead and draw my triangle. If I'm given one of the other ones, I'm going to write all the trig functions out and then flip it to find the other one.
I remember you talking about that, saying that it makes you mad when people don't call it sine.
Well, it's funny because the other day in pre-cal, somebody did it just to irritate me because I ingrained that in them last year because they would say sin, cos, tan. Made me cringe every time. And so the other day somebody said it and I looked at them because, they did it with secant. They went secco and I was like, they were like, stop, she doesn't like that. I was like, good job. I told them last year because they kept doing it intentionally, like after I told them to stop. And I said, fine, I'm going to start taking points off. It stopped really fast. All right, so cosecant is 10 over 7, so that means sine is what?
7 over 10.
7 over 10. So I'm going to use that to set up my triangle.
7 on the side, 10 on top.
I really gotta think about drawing a triangle.
3 lines.
Yeah, but it makes me think. Like, I like to make it the way she does, so, like, yeah. I try to, yeah. Yeah,
Like,
it's the opposite way my hand is used to, so I gotta, like, think about it.
All right, so I have to find the other side. So A is equal to the square root of hypotenuse squared. You notice I get progressively lazier as we go and start skipping more steps. So square root of 10 squared minus square root of 7 squared, which is 49. So square root of 51. Think about, can this be broken down?
No. Can it?
6 times.
Oh, 3.
3 can come out, I think. Well, it would, wait.
Yeah.
Yeah.
3, it's like
Yes.
17.
Hey.
It should be 17.
Yeah, I think it is. So
But then
still nothing's gonna happen, yeah. Alright, so nothing else I can do with that, so I just have to leave it. I did not leave myself a lot of room. It's the square root of 51. Alright, so cosine Adjacent over hypotenuse.
Square root of 51. Opposite.
Yep. Tangent.
Square root 51 over 7.
7.
Opposite over adjacent.
7 over square root 51, which is 7 root 51 over 51.
Secant.
10 over square root 51, which is 10 root 51 over 50.
And cotangent. I would use the original, not rationalized version.
Root 51 over 7.
It's not wrong if you do this. You just have to rationalize and cancel and all the fun things. So.
Are there gonna ever be imaginary numbers with them?
Thank Jesus.
Nope. And I'm going to tell you, like, if you think about, like, a triangle, right? If we're measuring the sides of a triangle, right? I can't have negative numbers. But I caution in saying that because eventually we're going to get to problems. It's not in this section. I don't remember what section it is in your book. But it is going to be based on, once we've done our unit circle, it's going to be based on what quadrant it falls in. So we could end up having negative side lengths, quote unquote, in terms of where it is. But for the purpose of these problems, these are not going to be negatives. So if you get a negative, something's wrong on these ones.
Drop something.
He lost his book too. See, it's not just me.
Why is your
It's okay, Cooper. We're all aware.
Um.
Sometimes.
On occasion.
All right, 18. Find the exact values of x and y.
Oh no.
Wait, Nick, you just said she just said
Oh, that is not a right triangle.
Well, it is. It just doesn't. Are you talking about yours?
Oh, I couldn't see it.
Oh, I just put the thing on there. If they don't put the little thing, don't just assume it's a right triangle, because later in this chapter we're going to get to triangles that are not right triangles, so don't just assume by looks that it is or is not.
I hate shapes. X.
What's your most least favorite shape?
What's your most
Jonah.
least
Mine?
favorite shape?
Yeah.
Oh, I have no idea. Having to do all the shapes right now in geometry, it's kind of a lot.
Octagons.
Pentagon?
Draw a decagon.
Yeah, no.
Dodecahedron.
Oh, I remember talking about that. What's that?
Oh, well. The one cube thing that I have over there is a dodecahedron.
Which one?
It's the big.
The big funny looking one.
That one?
They're all
Yeah, the
pretty
one
funny
with-
looking.
The one with like
So
this-
the one next to the triangle in front
Yeah.
of the clear block.
Yeah.
That's a dodecahedron.
Yeah.
That's great.
Wait, so how many sides does that have?
12.
Oh, yeah.
Or, well, I think that one is that one. That one's not mine, so I'm not sure.
12.
Whose is it?
That one's Daniel's. He brought a bunch in that he was bored of playing with at home, so he, like, donated them to my room last year.
Didn't Ducky always solve them?
Yeah.
Never understood a room.
They're very rarely solved anymore. All right, so I need to find x and y.
Yay.
But all I know right now is one side length. Okay? Now, to do kind of a throwback to geometry, what do you know about the angles of a triangle?
It equals 180.
They add up to equal 180.
So like 90 plus 45. 180 minus whatever that is.
So, I don't know if you remember, but you also learned about special triangles in geometry, or at least I hope you did.
You used the degree to find the
You
side
had
length?
two different special types of triangles. You had a 45 45 90 triangle and you had a 30 60 90 triangle.
I didn't pay that much
yeah.
attention.
Yeah, you're
So,
sleeping half
This
the
is
time.
90, this is 45, this also has to be 45.
Oh, forgot that one.
So, okay, let's do this then as a refresher, because if we're confused, let's do this. I'm going to draw it the same way as that one, so that way we can see it. So this is 45, this is 45. A special triangle that's 45, 45, 90 has side lengths that are as ratios. 1, 1, and root 2.
Oh, not that.
So, I'm going to kind of set this up as a proportion to solve for x. Now, hopefully you also remember things about triangles, that if the angle measures are the same, then their side lengths have to be the same.
Right.
Okay, within one individual triangle, obviously. The biggest angle has the largest side, smallest angle, smallest side, all those things. Remember those? Okay. You'll get a refresher on a lot of geometry. That's
Kinda just
the important geometry stuff you'll get a refresher on. So that means I need to figure out like a ratio to solve for x, okay, using proportions. So I'm going to do x over the square root of 21 is equal to 1 over the square root of 2.
This is great.
I can multiply by the square root of 21 on both sides so that I end up with x being equal to the square root of 21 over the square root of 2. Now, I can't leave it that way because I can't have a radical on the bottom.
Multiply it by root 2, right?
Yep, so I'm multiplying by root 2 over 2. So that means I have x is equal to, when I multiply two radicals by each other, I'm multiplying what's inside of them and keeping them under the radical. So that's going to be the square root of 42 over 2.
Can you break down 42? Yes.
Well, I know it's 2 and 21, and then 21 is 3 and 7.
And you can't break it down any further.
So I don't think I can take it down any farther than that. So that means that has to be what that is. Now, obviously, because I know this about special triangles, then I know that y also is equal to the square root of 42 over 2. And you don't even need to show anything because we've already decided that it's a special triangle. This
What is
has to be the
7
same.
and 6 and then 3 and 3 were?
Yes, we went over this, but we can't do that.
Well, 42 is 21 and 2.
Oh.
This is 3 and 7. There's nothing I can take out of the radical. So I can break it down, but there's nothing I can take out.
I still don't understand how to do that.
Sometimes.
You take out groups of however many the root is on
Yeah,
the
but
radical.
then, like, what's the number inside of this? That's great.
Whatever's left over, you multiply those numbers back together.
Isn't it so cute? It's so cute.
So like if I had, let's say if it was the square root of 8, I take 8 and I break that down into 2 and 4. 4 is 2 and 2. I take out a set of 2's, so it's 2 root 2.
Just need help.
I just needed help.
All right, 19. Yes, I know it's an odd problem.
That's okay.
It's an odd problem. Must be super difficult. That's why.
Oh, wait.
You're just
Gotta
wishing
think.
that.
Hold on.
Okay, so x is equal
Add
to
it.
12.
Are you thinking about triangle?
Maybe. No, never mind.
X is not
Yeah.
equal to 12.
Hold on,
Are you,
that's not right.
you struggling with your
30,
triangles
so
over
the
there?
other one-
No, I
50.
just didn't see the 30
I
degrees.
wasn't.
I can't count.
60.
Oh,
Basically, these two angles have to add up to 90 because this one is 90. Okay, so that means that this angle down here, as I'm about to write 30 again, is 60.
30, 60, 90.
So this is a 30, 60, 90 triangle. So I'm going to make a little reference one here to look at. No. All right, so stuff about a 30, 60, 90 triangle. They have side lengths of 1, 2, and root 3.
I hate these.
Okay, the 2 is the hypotenuse. If you get confused, just remember that the square root of 4 is 2, so the square root of 3 has to be less than 2, so it has to go over there. All right, so now I'm going to use this again as a reference to solve these.
So,
What was the hardest math you ever took?
A college math class.
Like, what was it about though?
It was all proofs, all paragraph proofs.
Oh yeah. So you
No
asked
numbers.
this before. I have.
yeah.
Oh. Well, I needed a refresher.
A class you don't want to take, I promise you that.
Oh,
Yeah, we don't plan on it.
All right, so I can choose kind of any of these to go through and solve. but which one do you want to do, X or Y?
Which one's easier? How?
It really doesn't matter.
Why?
All right, let's do Y. So I'm going to stick Y on top. So I'm going to do Y over 12
Y over 12.
is equal to, I have to do them in the same order, so 2 over root 3.
Times root 3.
Then what, you multiply 12 by both sides?
Yep, multiplying by 12 because I need to get the Y by itself. So that is 24 over root 3.
Oh, that's a big deal.
Got to rationalize it.
Uh,
So that's 24 root 3 over 3. 3 goes into 24
8 times.
8 times, so this is 8 root 3.
so like what now?
So Y is equal to 8 root 3. Now, obviously, I was able to do that. The last one, I was able to say, well, they're the same value. Well, these ones are not, so I have to figure out how to relate that. Now, if you notice here, this side is 2 and this side is 1. So this side is half of this side.
4 root 3.
So I can take half of Y. So half of Y is equal to X. So half of 8 root 3 is 4 root 3. And that's X. Now, I could have done it the same way that I found Y if I didn't realize that it was half of it, or if I was like solving for some the other side or something. I could have done it the other way and set it up as X over one of the sides and solved for it. Aside from if I'm going to do this kind of like cheat way of like saying it's just half of Y,
I think.
I would not recommend using a number that you solved for if you have a number that you've been given, because if you got this number wrong, then you're automatically getting this other one wrong as well. You could also have used the Pythagorean theorem because we know it's a right triangle since you found this side to solve for this one if you were so inclined.
Are we using tomorrow to do our homework? Thank God.
That's why I just decided I'm going to just finish the section so y'all can work tomorrow.
I have like no time for homework.
I'm fine.
Okay. Solve triangle ABC using the diagram and the given measurement. So on this one, they're giving me the triangle already. I'm going to do one of these today. I'm hoping I'll get through it. I may start with one tomorrow just up on the board for you, but just be aware of that. 26, they tell me that angle A is 49 degrees and side C is 27. And then this is the triangle that they've given me for all of these problems. So big capital letters are angles, lowercase letters are side lengths.
Wait, how is
eight.
how does C a right angle if it's 27?
No,
That's
I'm
a side
so
length.
retarded.
And obviously it's hard to see it. If there's not a degree symbol, then it has to be a side length. It's a little easier to tell in the book they're capitals and lowercases than it is on
We're all in this
my
together.
handwriting. All right, so I'm going to write out all of my angles and all of my sides. So angle A is 49 degrees. Side C is 27. Now, I also know angle C because they've put this lovely little box over here for me.
Of 90 degrees.
So it's 90 degrees.
And then you add both the degrees and subtract from 180 and
Yeah.
B is.
Yep. Angle B then will be the next easiest thing to find. So angle B is 180 minus 90 minus 49.
I can't do math like that. 90 minus 49.
It's 41.
So 41 degrees. Okay, let me do this. So now I just need to solve for side A and side B using one of my trig functions and your calculator.
Calculator!
All right, really quick, I'm going to show you something on your calculator. Because some of you have possibly shared your calculator with an upperclassman, you borrowed your calculator from somebody who's had it previously, you need to check and see if your calculator is in the correct mode. Okay, so you're going to hit mode up here beside the second button. You're going to arrow down and you're going to see this thing that says radian, and then you're going to see this thing that says degree. If degree is not what's lit up, so in my case radian's lit up, you need to arrow over to degree and hit enter so that radian is not highlighted anymore. Okay, if you
Degrees highlighted, right?
degree is what you need highlighted.
Perfect.
Now, eventually we're going to be doing problems later on in trig that we're alternating back and forth between them.
Oh, that's lovely.
But if you do not do this, your answers will all be wrong.
Oh.
Radian and degrees give you drastically different answers when we plug them into a trig function. Okay? So, to find side A, I have to think about things that I know. Well, I know that side C is 27. So I need to use something that I know that relates with the hypotenuse. So I can't use tangent. I've either got to use sine or cosine. So which one do you want to use?
Cosine.
All right, cosine of angle B then to find side A. So we're going to do the cosine of angle B is equal to adjacent over hypotenuse. So A over 27. I'm going to replace this. B is 41 degrees.
Oh, I remember.
So now we multiply by 27. So 27 times the cosine of 41. You just type that into your calculator. 27 and then the cosine button 41. And that is 20.37.
Yeah.
Okay, and then you would solve for the other ones. We'll finish this one up at the very beginning tomorrow, and then you'll have time to work. Just remind me that we need to finish this one, and then I'll give you your problems at the start tomorrow. But you'll have pretty much the entire class to work, so you shouldn't have to go home with anything. Go ahead, I would say, and do the notes for the next section tonight, so you don't have to worry about them this weekend. You probably won't have time to do problems and notes, but that's up to you.
Do that in study